Good morning, students. Now, today we are going to discuss the questions related to plant design economics, process dynamics and control, and engineering mathematics. Right. Now, questions of what? GATE mock test. So, we have conducted a GATE mock test, and I am going to discuss the question related to these subjects. Right. So, starting off, question number 2. So, question number 2 is related to PDC. Right. So, they are saying a proportional plus derivative controller, that is PD controller. Right. PD controller, the options are given that has high sensitivity, increases the stability of the system, improves the steady state accuracy. So, they have given the 3 points related to your PD controller. Now, they have written for PD controllers 3 points are given. Now, out of these 3 points, we have to select which one of these points are correct. Right? Options are given to you. That option is all of these. Option B, 1 and 2. Option C, 1 and 3. And option D is 2 and 3. So, basically you know that, right, the effects of PD controllers. So, we have some points and you have to learn these points as it is, because in the GATE exams they can write those points and they will going to ask you out of these points which one of the following points are correct. Same goes for PD controller, same goes for PI controller, same goes for PID controller, as well as same goes for only P controller. So, these points are important, and you all know that for a PD controller, what are the effects of PD controller? So, we know that first effect, that is has high sensitivity. You all know these things, right? And second one is what? We know that it is a high sensitivity. Second one is your reduces the rise time and settling time, right? As well as it improves the stability. Right. So, using the PD controller has different effects. So, most common effects are increases the it has high sensitivity, right, as well as it increases what? It improves the stability, or we can say increases the stability of the system, right. So, we have 3 points, that is high sensitivity, that is correct, increases the stability of the system, or we can say what? Or we can say improve the stability, right. Plus, they are saying improve the steady state accuracy. That is not correct. Right. So, out of these 3 points, we have first point is correct, second point is correct. So, we can say option B is the correct answer. Guys, students, please you have to learn these things. The points related to P controller, PI controller, PD controller and PID controller. Because these points are very much important for GATE point of view, as I have discussed in the class also, right, under the section of controllers. So, offline students, I think I have taught you these things now, the important points related to P controller, PID controller and PD controller, right. So, remember this thing, learn those points because they has been asked these points, right. Now, starting for question number 5th. So, question number 5th is related to your mathematics, engineering mathematics. What they are saying? They are saying let M4 is equals to small m, M4 is equals to I, that is identity matrix, right, as well as, just a second. Yes, they are saying M4 is equals to I and M is equals to, M is not equals to I, as well as M square is not equals to I, as well as M cube is not equals to I. Then they are asking for any natural number of K, what is the value of M inverse. This is the question. 4 options are given. What is option A? M 4k plus 1. Option B, M 4k plus 2. Option C, M 4k plus 3. Option D, M 4k. So listen to me very carefully how to solve this question. Now, if you have such question that contains M4 or any power of M that is equals to I, and they are asking about M inverse. So M and M inverse is actually there in the question. So first thing that comes here in your mind for such type of questions is that we know that what we know that A into A inverse is equals to what? I. We know this thing, right? Or I can say in this case M into M inverse is equals to identity matrix. The first thing that comes in your mind when you see A inverse or M inverse or M any power of M that is equals to I, you have to write down this thing. Now in the options they have given, in each of the options we have M power 4k plus 0, 4k plus 1, 4k plus 2, 4k plus 3. So according to the observation I can say let M inverse will be equals to what? M inverse is equals to M power 4k plus C. C stands for any number. It can be 0, 1, 2, 3 and we have to calculate this thing. Right. Now we know this thing. Put the equation in this particular equation. Put the value of M inverse in this equation. Let this equation will be equation 1. So from here I can say that M into M power 4k plus C is equals to I. Now we know that M into M 4k into M power C is equals to I. I can write like this thing, and we know that from this equation we can put the value of this thing is I power k into MC is equals to I. Or we can say from here, you know, for whatever the value of power of k, so see for whatever the value of I power k, so k की कोई सी भी value, for any value of k I will get I only, that is identity matrix. For any value of k I will get identity matrix, either 0, 1, 2, 3, 4, 5 I will get I. For any value of k I will get I. So I can say from here that M into MC is equals to I. Yes or no? Or I can say M power 1 plus C is equals to I. We got this equation. We know this equation. We can compare this equation with this equation. What we will get? M power 4 is equals to M power 1 plus C. Or I can say by equating this thing, we can say it will become what? 1 plus C is equals to 4. C is equals to 3. So from there we can get the value of C, and that is equals to 3. So I can write, because we are assuming this thing now. We assume this thing that let is equal M power inverse is equals to, this is the thing that we are assuming. M inverse is equals to what? M power 4k plus C. We got the value of C. So I can write this as M inverse M power 4k plus 3. Which option is correct? Online students and offline students, tell me. You. Tell me which option is correct. Of course, option 3. C option is the correct. So think about this. Whenever you see m power 4 is equals to y, or any power, right? And they're asking about m inverse. First thing that comes in your mind is this thing. And you know this thing, what is the meaning of this thing? We have studied in engineering mathematics class, right? I strictly said you this thing, as such kind of equations, such kind of things can be asked directly in the GATE exam, right? Now, starting with next question, that is question number 6. So question number 6 is from process dynamics and control. And we have studied this thing now. Just a second. We have studied this thing. So they are asking Bode stability criteria is applicable when? Tell me, online students and offline students. मैंने पढ़ाया था आपको. We have studied this thing. Anyone? What happened? You don't remember? Remember. Okay. So tell me the answer. Hurry up. What's the answer in this case? Anyone? Any idea? So we know that Bode stability criteria is applicable for both the graphs, right? When monotonically decreasing, right? So from here we know that we can draw the graph, amplitude ratio versus omega, as well as यहाँ पे क्या आएगा? Tell me, phi versus omega, yes or no? You tell me. This is the thing. So I can say from here Bode stability criteria is applicable for where both graphs are monotonically decreasing. Got the point? Got the point? Online students, everyone is correct? Everyone is getting same thing? Okay, so all are correct in this case. So monotonically decreasing. So which option is correct? Gain and phase curve. This is gain curve. This is phase curve. Right. So gain curve and phase curve decreases continuously with frequency. In that case, Bode stability criteria is applicable. Right. So according to this, option A is the correct one. Right. So all are correct in this case. Good job. Now, coming back to the questions. Yes. Question number 10. They are saying plant producer. A plant produces phenol. Right. The annual production cost for the plant are 38 lakhs. So 38 lakh is your annual production cost. Right. So I am rubbing this thing. Annual production cost. So I think from optimization we have done a lot of questions. Yes or no, online students? Right? We have done a lot of questions. अरे ना हाँ तो हाँ बोलो सोच क्या रहे हो? We have done a lot of questions, ना? Yes or no? Yes. Almost more than 20 questions we have done in the class. More than 20 questions. Now annual production cost. Annual production cost is equals to what? 38 lakhs. While sum of the annual fixed charges plus overhead charges and other expenses are 25 lakhs, right? And annual sales are of 80 lakhs. And the selling price of phenol is, see, selling price SP is equals to 500 rupees per unit. Determine the break-even point in units of production per year. We know one thing. What do we know? Tell me. Total selling cost. This is the thing of selling price, right? Is equals to what? So N into selling price. This is the selling price for per unit. Number of units are there. So total cost after the sold of all the things is equals to N into CP cost price plus of what? Plus of sum of annual fixed charges, overhead charges and other expenses. So sum of additional cost. This contains what? This contains annual fixed charges, overhead charges and other expenses. That is around 25 lakhs. This is the equation of break-even point. What is the meaning of break-even point? The point at which whatever the things that I have invested is equals to what? After selling of the products that I am getting. So after the selling of products, I am getting this much amount of money and this much amount of money that I have invested in the production of this product, because see, this is the total cost that I am applying, and this cost includes what? They have given annual fixed charges, overhead charges plus other expenses, and this is the what? This is what thing? This is your cost price, right? This is the cost price. So cost price for per unit into number of units gives the total cost price, right? So if this particular thing situation occurs, then we can say we are achieving a break-even point where no profit, no loss is there. At this point, we have no profit, no loss, right? Now, from this point, they are saying annual sale is 80 lakhs. So, annual sale is equals to 80 lakhs, right? So, number of unit produced is what? We know selling price 500, annual sale 80 lakhs. Number of units produced, that is equals to 80 lakhs divided by 500 rupees per unit. From there you will get what? Karo calculation. Tell me the answer. From there you will get what? Hurry up. I think calculation is easy, na? You have the easy calculation. Hurry up, tell me the answer. Yes, 16,000. Everyone is getting 16,000. Aap kaha raha hai? Okay, all are getting 16,000. Right? Okay, 16,000. 16,000. Number of units, right, produced. These are the things that you will get. Right? So after this, what we are going to do? Tell me. So they are saying about production cost per unit. We have to calculate the production cost per unit, and they have given what? Annual production cost, and we know that number of unit produced is 16,000. So production cost per unit is equals to what? 38 lakhs divided by number of unit produced. These are the number of units. From there we can say that the production cost per unit comes out to be, let me take the calculation. So you are getting around 237.5 something, right? So from here you are getting 237.5. This is the production cost per unit, right? Now put the values in this equation, you will get the answer. SP you are getting, so N into SP, that is, sorry, this is 500, no? Yes, this is 500. See, we are not going to place this number of units because this is the total number of units that we are producing. We are here calculating the total number of units. Okay. If I sell those units, right, I am getting some amount, and that particular amount is equals to the total amount that I spend on that particular n units, right, and that is your break even point. Now we are not going to use 16,000 here, right? This is equals to n into production cost per unit, that is equals to 237.5 plus total additional cost is your what? 25 lakhs, I think. Yes, 25 lakhs. So this is your around 25 into 10 raised to the power. You can solve this thing. What's the answer that you are getting? So by calculating I am getting 9524 approximate. So from there we can get getting 9524 units. So at this point, right, you are achieving break even point. Means no profit, no loss. This is the thing. This is the units that you have to produce in order to gain no profit, no loss. So from here I can also say that subtracting 16,000 from this 9,524, you will get what? Now, this is what? 4, right? And this is your 6, right? So almost 6,476 is the total units that will gives you the actual profit. That will gives you the actual profit, right? Because this is the investment that you have made. You will get some return, and this return is equal to the investment. So after the production of 9,524, whatever the quantities that you are producing, that particular quantity will give you the actual profit. So these are the quantities that will gives you the actual profit. So selling price is your what? 500 into 6,476 is the actual profit that you are getting after the break even point. Got the point? Everything is clear? Okay, everything is clear. Online students, everything is clear? Okay. Now, question number 11th from chemical technology. They are saying catalyst used for the preparation of acrylonitrile. Now, first of all, tell me the structure of acrylonitrile. Anyone? We have discussed this thing in the class. Batao. You, क्या सोच रहे हो? पता है ना? हाँ तो बताओ फिर. Acrylonitrile, simple. CH2, CHCN. Yes or no? सोच लो आराम से पहले. This is the thing, na? Now, catalyst. What is the catalyst? We have discussed this thing. Molybdenum bismuth catalyst we are using for the formation of acrylonitrile. Now just tell me one thing. What is the raw material that we are using here? Now that's your homework. Right? You have to check. Because I have discussed each and every reaction in your petrochemical topic. You see, these are from petrochemical topics. Na? See, equally important in the GATE exam. Don't leave that topic. Right? So option C is the correct one. Simple question, theory question. There is no need for discussion on this thing. Right? If you know the theory, you can correct the answer. If you don't know the theory, you can't get the correct answer. Now, next question. Yes. They are saying which of the following compounds can minimize the fluctuations in surface tension of emulsion in emulsion polymerization. See, I have given you the PDF that contains solution polymerization, emulsion polymerization, right, suspension polymerization. I have given you this thing, bulk polymerization, right, and I have told you that you have to learn those theories as it is, right. So tell me, which of the following compounds can minimize the fluctuation in surface tension? Cetyl alcohol, pure theory question. If you know the theory, if you go through that particular PDF that I have submitted to you, right, you can easily get the answer. So option B is the correct one, cetyl alcohol, pure theory question. और मैंने बताया था आपको, I have told you that you have to learn these things as it is from the PDF, right? बताया था ना सबको? बताया था कि नहीं बताया था? आप यस बताया था सबको, देखो, और बोला था मैंने आपको, आई हैव टोल्ड यू वन क्वेश्चन कैन कम इन द एग्जाम, राइट. नाउ नेक्स्ट क्वेश्चन, sorry, yes, now question number 23. The sensitivity and proportional band of a pneumatic controller with a scale of range from 0 to 120 degrees Celsius when the output changes from 20 to 100 kilonewton per meter square as the temperature rises from 95 degree to 110 degrees Celsius are. They are asking about this thing, right? Now first tell me, what is sensitivity in the controller? Anyone? Because we have discussed these things in the class. What is the meaning of proportional band? What is the meaning of sensitivity? Yes or no? Online students and offline students, tell me, hurry up. We don't have much time. Yes, na? Yes. So tell me, what's the answer in this case? Anyone? So write down one thing, the basic thing. So we know that, see, proportional band pneumatic controller scale with this. So we know one thing, that delta output is equals to Kc delta input. What is the output here? Output changes from 20 to 100. These are the range, right? So according to this range, we can say 120. This is the output. Change in the output. Kc times of change in the input. What is the change in the input? As the temperature rises from 95 to 110 degrees Celsius, right? So 110 minus 95. What's the answer in this case? Tell me. Hurry up. What's the answer that you are getting? So we can say Kc is equals to 100 minus 20 divided by 110 minus 95. Kc is equals to what? 5.33. 5.33 kilonewton per meter square into degree Celsius. So Kc has units, and these units depends upon what? Input and output units, right? This is your sensitivity. What about proportional band? Proportional band. Don't give me that particular definition of formula. Formula नहीं चाहिए मुझे. What is the meaning, actual meaning of this thing? Anyone? We have discussed this thing in the class, na? Proportional band is equally important. Proportional band is the equally important related to sensitivity. So write down one thing. They are saying this and this. Okay. Write down the ratio of, likho, write down the ratio of actual range to the ideal range. Proportional band is defined as the ratio of actual range to the ideal range, or we can say that how much band is being used, or we can say how much band is being used, or percentage band used, or we can say percentage band used. So they are saying out ratio of what? Actual range to the ideal range, right? Or how much band has been used, or percentage of band has been used, right? So from here, just a second. So we can say that actual range. What is the actual range here? Anyone? Actual range means that is happening actually. And what is the ideal range? Ideal range is from scale range. That's the scale range. Is your ideal range from 0 to 120, right? So actual range divided by ideal range. याद आया कुछ? यू ऐसे क्या दिख रहे हो? डिस्कस किया था ना, आप बताइए. We have discussed this thing in the class. Yes. What is the actual range? That is from 95 to 100 degrees Celsius. So we can say 110 minus 95 divided by ideal. Scale range is your ideal range, na? Scale range is your ideal range. Scale range is your from 0 to 120 degree Celsius. So 120 minus 0. What you are getting? Hurry up. Into 100. That's a percentage. Answer. Kitna? 12.5. 12.5. Okay. 12.5 percentage. So according to this, sensitivity we are getting 5.33. So option A and C can be correct, but sensitivity is 12.5. So option C is the correct one. So option C is the correct answer. Remember this thing. Proportional band is the ratio of what? Actual range by ideal range. Or we can say that, write down, or we can say that how much band is been used. How much band is been used or percentage band used. Simple. And see, there is a question, I think in 2007 and 2008, I think, right? They have a question where they ask you the proportional band. If you know these things, you can easily get the answer. Correct? Okay. Coming to the next one. Now, question number 25. They are saying depreciation is considered as what? We have done this thing in the class. Right? Depreciation, fixed cost, variable cost, both, or working capital. Obviously, it's a fixed cost. It's a fixed cost. The option is the A is the correct one. Right? We have discussed this thing in the class. Remember. Just a second. Okay. I have mistakenly give you the answer of that question. Right. So next question is your, not this. Next question is your 26. Right. They are saying, okay, this is a question for linear interpolation between that thing. Okay. See, in numerical methods, class is going on right now for the numerical methods, right? So in that particular class, we have completed till your RK method, no, till your Euler's method, implicit as well as explicit. Yes. After that, we are going to discuss the modification of Euler's method, right? In that particular thing, in the next topic, we are going to discuss the linear interpolation method also. Simple method, right? So what is this thing? So they are saying the true value of ln2. See, basically that question of economics. See, the question आगे था, मैंने आपको पहले बता दिया कि पेज टर्न हो गया था, right? So don't worry about that thing. वो सोच रहे कि कहाँ गया क्वेश्चन वाला. क्वेश्चन यहीं पर ही आपके पास ही है, right? Now they are saying the true value of ln2 is 0.69. True value 0.69 of ln2. The value of ln2 obtained by linear interpolation between ln1 and ln6. Between ln1 and ln6. Right. The percentage of absolute error is what? Now, this is your what? True value. With the help of numerical methods, we are calculating what? Approximated value. We have to calculate approximate value. Yes or no? Now, what is the formula for percentage absolute error? Anyone? We know that what? Yes. आप बता रहे हो ना? हाँ बताओ. True value minus absolute value divided by true value into 100. Is this formula correct or not? Tell me. Hurry up. Is it correct? आप बताओ. You, हाँ. We have discussed this thing ना in the class. हमने सारी चीजें पढ़ी हैं. Of course, this is the correct one, right? We have to use this thing. Remember this thing, right? The formula for percentage absolute error. Percentage absolute error. This is the formula. You have to calculate this thing. In order to calculate this thing, you need approximated value, right? We know the true value, that is 0.693. How can we calculate absolute value? Approximated value. Anyone? See, what is the value of ln1? ln1 is, tell me, let's suppose if this is the point, what is the value of ln1? 0. The value of ln1 is 0. So at 1, this is the ln line, at 1 it is 0, this is 2 and here it is 6. What is the value of ln6? Tell me, value of ln6. 1.792, right? So 1.792. This is the value of ln6, right? We know this value. We need to calculate the value of this thing, right? This is the ln line. This is, let's suppose, fx line. Fx is your function, ln function. For any value of x, right? You will get different values of f of x, right? So we can say f of x is equals to ln x. For different values of x, right, you will get different values. Got the point? Now, you have to calculate approximated value. You have to calculate approximated value, right? So, we know 2 points, we know 2 values. We know 2 values, right? First value is what? At ln1 we are getting 0 value of y. At ln6 we are getting y is equals to this thing 1.792, right? What is the slope of this line? From here we can say that the slope is 1.792 minus 0 divided by 6 minus 1. Yes or no? Now, let's suppose the value of ln2 will be x, right? So, the slope of, let's suppose this is A point, this is B point, this is C point. The slope of line AB is equal to the slope of line AC, and this is equals to what? From here we can say that this is the x value, right, in this y-axis. So we can say the slope of this one is x minus 0, slope of AC line is equals to slope of AB line, x minus 0 divided by what? 2 minus 1. Yes or no? Everything is clear till now? Any doubt you can ask me. Right? Now, from here we can say, sir, 1.792 into 1 divided by 5 is equals to x. You get the value of x, and that is equals to what? Now, if I am calculating this thing, I am getting 1.792 divided by 5. You are getting 0.358 is equals to x. So the value of ln2 you are getting from here is 0.358. Right? And you know the value, what is this? 0.693. You know the value of ln2, 0.693. And here they are written 0.69. Large difference. Almost you can say about 50%. Difference of 50, na? Difference of 50. Right? So they are saying percentage absolute error. 35% is 69, 84 or 48. So on seeing the options we can say 48 is the answer, because almost 50% difference is there in the value of ln2. Here with the help of linear interpolation we are getting x is equals to 0.358. This is the value of ln2 with the help of linear interpolation. Right? See, I am going to discuss these things in the class, in the numerical methods class. Don't worry about that thing. Right? Abhi hua nahi hai. Right? After the completion of modify Euler's method, we are going to discuss these things. Right? As well as linear regression. Because linear regression is a different thing. Right? I know. We are going to discuss this thing. Don't worry. Don't feel the fear. Right? Okay. This is the way to solve this thing. Or we can say that what? According to the approximation, we can say this is equals to f of x naught plus x minus x naught f dash x naught divided by 1 factorial. We have done such kind of thing, na? And so on. Right? According to this, we can get the answer also. Right? Or you can do by this way. Right? So this completes your 26th question. Now you can put the value. Okay, put करके बताना पड़ेगा आपको. Okay, don't worry. Minus 0.358 divided by 0.69 into 100. You will get approximate to 48%. Now got the answer? Okay. Now, question number 27. Remember this thing. True value minus approximated value divided by true value into 100. This is the formula for absolute error. Right? And this is the way to solve this question. Now, in the question number 27, they are asking definite integral and they have given you the integral. Right? So, I am going to write down the integral here. मैं करवाऊंगा अभी हमारा हुआ नहीं ना. We haven't discussed linear interpolation na, as well as linear regression, right? So after the completion of numerical method, I am going to discuss the linear regression, and within the numerical methods, we are going to discuss the linear interpolation. Don't worry. अभी तो numerical integration start हुआ हमारा, right? Now they are saying iota is given as under root of -1. I is equals to what? Integration from 0 to pi by 2 cos x plus iota sin x divided by cos x minus iota sin x. What is the integration for this one? Simple question. If you know the complex number, you can easily get the answer. So I can write this as what? Integration from 0 to pi by 2 e raised to the power. Tell me. Well, how can I write this thing? They have given the integration, na? Yes. So we can write e raised to the power what? Iota x divided by e raised to the power minus iota x. This is what? E raised to the power. See, we have done these things, na, in the class, in the complex equations. Complex number classes, right? So, this e raised to the power minus iota x comes in the numerator. You will get what? From 0 to pi by 2 e raised to the power iota x plus iota x 2 iota x dx. What is the integration for this one? Integration of e raised to the power 2 iota x. E raised to the power 2 iota x divided by 2 iota. Right? From 0 to pi by 2. Now, if you are putting pi by 2, you are getting what? E raised to the power iota pi. Right? Divided by 2 iota minus of e raised to the power 0, 1 divided by 2 iota. Solving this one, you will get what? Iota. That is your answer. According to this one, option C is the correct answer. Right. See, you have to place this value, na? Value of x. So what is the thing that you are getting? E raised to the power 2 into iota into pi by 2. E raised to the power iota pi or pi over iota. This is the thing you are getting. Right. So this is the way to solve this thing. Now, this completes your question number 27. Right. Now comes out to be question number 33. So they are saying a plant has an open loop transfer function given as GP, that is transfer function given as 20 divided by s plus 0.1 into s plus 2 into s plus 100. So 20 divided by s plus 0.1 into s plus 2 into s plus 100. So by looking that particular thing, what you can comment about these systems? It contains how many first order systems? Tell me. Now they are saying the approximate model obtained by retaining only one of the above poles, which is much closer to the frequency response of the original transfer function at low frequency. For low frequency, now we know one thing. We have this transfer function. It contains how much your first order systems? Tell me. How many first order systems that you have? We have 3 first order systems, right? This one, and this one, right? What is the standard form? Kp by tau p s plus 1. So we can say from here 20 divided by 0.1 10 s plus 1 0.5. This is the thing, no? Or 0.1 plus 1, and here it is 0.01 s plus 1. So this is the thing that you are getting, right? Now we have to take 0.1, we have to take 2 here, so we can say into 2, take 100 into 100. What you will get? You will get from here GPS is equals to 20 divided by 20 10s plus 1 0.5s plus 1 0.01s plus 1. This is the transfer function that you are getting, 1 upon 10s plus 1 into 0.5s plus 1 into 0.01s plus 1, right? So now you know that what is this thing? Time constant. T1 is equals to 10, T2 is equals to 0.5, T3 is equals to 0.01. So from here you can calculate the frequency. See, we know that for corner frequency tau omega or omega tau is equals to 1. From there you can calculate the value of omega here, right? Now what is the value of omega in the first one? 0.1. Omega 2. What is the value of omega 2? 2. What is the value of omega 3? 100. Right. Now, on seeing these 3 values, we can say low frequency value is 0.1. Right. And they are asking about what? Approximate model obtained by retaining only one of the above poles, which is much closer to the frequency response of the original transfer function at low frequency. So this at low frequency, this is the low frequency, right? So on seeing this thing, we can see we have to approximate this one original transfer function. This is corresponding to what? This one corresponding to this one. So from here, we can say that we can approximate this thing. Up to what thing? We can approximate this thing, na? We can do the approximation. So what is the approximation for this one? Approximation for this one is 0.1 divided by s plus 0.1. Yes or no? Or I can say from here 1 upon 10s plus 1. Right. So according to this, which option is correct? Option A. So option A is the correct answer. They are asking about what? Approximated to for original function at low frequency. This is the way. Simple. It doesn't require any knowledge for frequency response or anything. If you know a little bit knowledge about this thing, you can easily get the answer. Right. Okay. Now the next question. Any doubt till now? No doubt. So next question is, the transfer function of a system is given as Gs is equals to e raised to the power s divided by 500 divided by s plus 500. So this is a transfer function that contains what? Tell me. We have two transfer functions, na? So we can write this as what? G of s is equals to G1s into G2s. They have given Gs value as e raised to the power minus s divided by 500 divided by what? S plus 500. You can write this as in standard form. You can write this as standard form. What is the standard form? E raised to the power minus s divided by 500. Take 500 common. Right, you will get what? S divided by 500 plus 1. Now they are saying input of a system is given as what? Input is given to you. X of t is equals to sine 100 pi t, or we can say this is what? A sine omega t. The value of omega here is what? 100 pi. This is very much important. They are saying in periodic steady state, the output of the system is found to be what? Y of t is equals to A sine 100 pi t minus phi. And the phase angle phi in degree is what? This is the value of omega. Right. So this transfer function contains two functions. Right. This is the thing and this is the thing. So we can say G1s into G2s. So tell me, what is the G1s here? What is the value of G1s here? So we can say G1s represents what? It represents this one, e raised to the power minus s divided by 500. And G2 represents what? 1 upon s plus 500. Right. Now, from these two transfer function, what is the value of theta here? What is the value of phi 1 in this case? Phi 1 is equals to what? Anyone? Online students? Any idea? Hurry up. Minus tau d omega? Minus tau d omega, na? Minus tau d omega. What is phi 2? For second transfer function? Tan inverse minus tau p omega. Yes or no? This is the thing. Or we can say overall phi is equals to what? Phi 1 plus phi 2. Right. Now, we have to calculate phi value. We know the value of what? Omega, that is equals to 100 pi. right? We know the value of TD, tau D, it is equals to what? Tell me what is the meaning of tau, what is the value of tau D here? 1 upon 500, right? And what is the value of tau P? That is also 1 upon 500 from this equation, right? Put the value, what is the value that you are getting? That is minus of 100 pi into omega is, the omega value is this one, tau D value is into 1 upon 500 from this one, right? And plus tan inverse negative of, what is the value of tau P? 1 upon 500 into 100 pi. Now all solving this one, phi, you will get what? So they have given the answer. Now on solving this one, you are getting 68.13 degree, right? So on solving this one, you will get the answer in radian. Convert this into the degree, you will get the answer, right? Because see, tan inverse of something gives you in the radian, na, or degree. Tell me, we have discussed this thing, right? We know that what? Theta, we know that tan theta is equals to some value, that let's suppose k value. You have to calculate theta is equals to tan inverse k. Now from there you can get the answer. We have discussed this thing in the class of lag time. And what is a lag? Right? When sinusoidal input is given to the transfer function of first order transfer function. We have discussed this thing. Now from there you are getting the answer, that is approximate to 68.13 something. Right? So my answer is 68.13 degree. Right? Now, yes, they are saying for the phase, and this is a lag, because in the equation is what? A sin omega t plus phi, and here they are saying omega t minus phi, na? Right? So you can adjust the negative sign here, right? So this is the thing, this is the value that you are getting, approximate 68.13, right? So this completes your 34 question. Now for question number 35. Now question number 35 is saying the condition for which the eigenvalues of a matrix given as, now they have given you the matrix A. Matrix A is given as 2, 1, 1k. This is the matrix value, right? Now they are asking about what? They are asking about the condition for the eigenvalues of a matrix are positive. Let's suppose eigenvalues are lambda 1 and lambda 2. Multiplication of this one greater than 0, they are saying. Now tell me one thing, you know that if you know the eigenvalues, we can calculate the determinant by the multiplication of eigenvalues, right? Now for positive, so we can say multiplication of this one gives the greater than 0, or multiplication of this one is equals to what? Determinant of A. What is the determinant of A in 2 cross 2 matrix? Tell me. This is 2k minus 1 greater than 0. From there you will get k greater than 1 by 2. And according to this, option A is the correct one. So for that you need to know the property, that is product of the eigenvalues will give you a determinant of that particular matrix, right? Now this completes your question number 35. Coming to the question number 36. They are saying for ordinary differential equation given as this thing, d square x by dt square minus 5 dx by dt plus 6x is equals to 0. Now you have equation d square x by dt square minus 5 dx by dt plus 6x is equals to 0. Initial conditions are given. X of 0 is equals to 0 and dx by dt at t is equals to 0 gives you 10. What is the solution? So you can easily calculate the solution for this one. What is the auxiliary equation in this case? Tell me. What is the auxiliary equation? d square minus 5d plus 6 into x is equals to 0. From there you can easily calculate the value of roots for this equation. Right, this is auxiliary equation you have, right. So according to this, if you are getting real and unequal roots, distant roots, you will say, okay sir, we are getting x is equals to c1 e raised to the power m1t plus c2 e raised to the power m2t. There you will get the value of m1 and m2, right. From there you will get the value of m1 and m2. So by calculating the value of m1 and m2, right, that comes out to be I think 2 or 3, right. Put the value, you have two conditions and you have two constants c1 and c2. You will easily calculate the value of c1 and c2. Put the values there, you will get the solution, right. So this is the, I can say, easy question. It's an easy question, right. Okay, coming back to the question number 37. Let's suppose you are getting equal roots. So in that case, what you will get? X is equals to c1 plus c2x e raised to the power mt. There also you have to calculate the value of c1 and c2. You got the point? That's your doubt, na? Okay. Now, question number 37. They are asking about evaluate the integral by using Simpson 1/3 rule, having a step size of x is equals to 1. Now, integration is what? Integration from 3 to 7 x square log of x dx. See, these questions are the easiest questions. You just have to put the values at different points and add those values and you will get the answer. Just put the values in the Simpson 1/3 rule. So we know that for Simpson, for trapezoidal rule, we are using what? Trapezoidal. We are using trapezoidal, or you can say we are using linear polynomial, right, in order to calculate the value of integration, approximation integration with the help of trapezoidal rule, right. And with the help of Simpson 1/3 rule, we are using the concept of what? Parabolic tracing, parabolic curve. We are using the concept of parabolic curve or quadratic equation, right, to calculate the value of approximated value of integration, right. So in Simpson 1/3 rule, we are using parabolic curve in order to calculate the approximated integration, approximate value of integration. But in case of Simpson 3/8 rule, we are using cubic curve, cubic equation to calculate the value of approximate integration. Value of integration. We have to calculate the value of integration, approximated integration basically, by using the concept of cubic polynomial. So they can say, see, they can ask you, in trapezoidal rule, we are using, there you can say order of polynomial. So first order polynomial we are going to use in order to calculate the value of approximated integration, right. So approximation of integration, we will calculate the value with the help of trapezoidal rule, and this rule is done on the basis of taking first order polynomial. You have to take what? You have to take this thing. You have to take the area. So this is the trapezoidal. So number of trapezoidal, n number of trapezoidal is gives you the approximated integration, and this is your trapezoidal rule, right. And this is your equation of line, na, basically. This is the first order polynomial. Same goes for Simpson 1/3 rule. It uses the concept of parabolic curve or quadratic equation. For Simpson 3/8 rule, it uses the concept of what? Cubic equation. So the order of polynomial in case of Simpson 1/3 rule is second order fitting polynomial. For Simpson 3/8 rule, we are using third order polynomial. So fitting polynomial order is third order. Remember this thing. They can ask you this thing in the GATE exam. Important thing, right? Now see, they have given you f of x, x square log x, right? Step size of, form a table, x, y, this is equals to y, right? Starting from what? 3, then 4, 5, 6, 7 for different values of this. So Simpson 1/3 rule gives you h by 3 y naught plus yn plus twice of even values of y plus 4 times of odd values of y. Solving this one, putting the value of y, you will get the answer. But remember these things. I have these things in the class, in numerical method class. I have discussed this thing now. These are the basics. They can ask you, right? So this completes your question number 37. Coming back to question number 38, they are saying, okay, match the following. See, in column 1 they are saying road surfacing, natural gas, petroleum, paraffin, wax. Second column they are saying black gold, Vaseline candle, bitumen and CNG. So basically what is happening, asphalt bitumen we are using case of in the road formation. So road surfacing ke liye we are using bitumen, right? Or you can say asphalt bitumen. Now for petroleum, this is a common name. Black gold is a common name for petroleum. Paraffinic wax is going to be used for Vaseline manufacturing or candle manufacturing, right? Now, what about natural gas? CNG, compressed natural gas. So that's Q belongs to 4. So for this 38 question, C option is the correct one. Basic question. If you don't know about CT, you can easily solve this question with a common sense, right? Now next question, they are saying question number 44, the characteristic equation of a closed loop system is given as this one. Just a second. They have given you the characteristic equation 0.25 s cube plus 0.8 s square plus 5.6 s plus 1 plus 0.35 k is equals to 0. Now they are saying about the limiting value of k above which the closed loop system is unstable. Right. Now tell me the answer. Hurry up. Now, see, for this question, first apply route test. Apply the route test. Right. Now you can say from here we have 0.25, 0.8, 5.6. Yes, 5.6. We have 1 plus 0.35 k. Right. Now this one is B1, B2, C1. First calculate the value of B1. Right. What is the value of B1 here? 0.8 into 5.6. Minus of 0.25 into 1 plus 0.35 k divided by what? This is A1, A2, A3, A4. So A2, that is 0.8. See, listen to me very carefully. In order to solve this question, this particular question, right, they are saying limiting value. So in the route test, these elements, right, these elements are to be positive, right, and this particular equation should contain all all the components of this equation should have same sign, whether all are negative, whether all are positive. If one of the components are negative, let's suppose instead of this positive, this is negative, so we can say we have a root, that is, tell me, you know this thing? Now, so from here we can apply the route test in order to calculate the value of limiting value of k, above which the closed loop system is unstable. So if you are getting the value of b1 that is less than 0, or you can say if you are getting the value of b1 and c1 negative, then we can say that what? From there we can say our closed loop system will become unstable for a particular value of k. So this comes out to be b1 and b2, or you can say b1 comes out to be positive, right? Or in this case, when the system will become unstable, b1 had to be less than 0. Now on solving this one, you will get the b1 value, that is equals to what? 48.31, or you can say 34 approximated, right? So above this one, the system will become unstable. Below this one, the system will be stable, right? So this is the way to solve this question. Now comes out to be question number 45. They are saying the transfer function of the process is given and measuring element is given to you, control valve is given to you, right? Just a second. GP is given to you 2 by 2s plus 1. GM is given to you, measuring element 1 upon 5s plus 1 divided by 3s plus 1. Now they are asking about what? They are asking about a proportional controller with a gain of Kc is used, P controller. Determine the steady state error in the output for a unit step change in the set point. Steady state error, simple, offset. They are asking about offset, that is equals to what? Y of, tell me, Y of Sp at infinite minus Y of infinite. Thus infinite is t tending to infinite. So corresponding to t tending to infinite, we have s tending to 0, right? Now for that, form a transfer function. You know one thing, that y of s is equals to what? GC, GP and GF divided by 1 plus GM, GC, GP, GF. Yes or no? This is the thing, na? This is the thing that we are getting, right? Now we have this question. Now they are asking about what is the value of valve. We know the value of valve. See, final control element, na? This is the value of valve, right? They have given you the process value. They have given you the transfer function of the controller, right? Apply in this one, you will get the answer. Y of s into what? Y of s. See, this is y of s. This is y of s. Set point, right? Now, there also said that when nothing is given, you can say step change is there. So, ys will become what? 1 upon s, right? Now, from there we can say 1.5 final control. GP is the process. 2 upon 2s plus 1, right? For controller we can say Kc. For valve we can say 1.5 divided by 3s plus 1 divided by This is the thing, divided by 1 plus 2 by s plus 1, 2s plus 1 into 1 upon 5s plus 1 for measuring element into Kc, right, into 1.5 divided by 3s plus 1. How can you calculate the value of y of s as at t tends to infinity? For that, what do you have to do? Put s is equals to 0 in this equation. So when you are putting s is equals to 0 in this equation, you will get what? You are saying, sir, s y of s. You are putting s is equals to 0 means for y of infinity. This is what? This is final value theorem, na? Ultimate value of response, right? This is equals to what? Putting the value of s. This will become 0. This will become 0. This is 0. This is 0. This is 0. So after solving this one, the basic equation that I am getting from here is 3 by 4. Right? How I am doing this thing? See, you have 2 into 1.5 into Kc, right? And the value of Kc here is what? Value of Kc, I think they have given the value of Kc. Now, yes, Kc is equals to 1. So, Kc you can take 1, you can take 1. From there you will get 2 into 1.5, 3. 1 plus 3, 4. This is the value that you are getting. What is the value of y of sp at t tends to infinity? Y of s, na? T tends to infinity. Value theorem. So you can say offset is equals to 1 minus 3 by 4. That is equals to what? 1 by 4. That's the answer. So 1 by 4 or 2.25. Now they are asking about 2 decimal places. So 0.25 is the answer. This is the way to solve this question. Right? Now coming back to next question. Now we have question number 49. Determine the stability range of K for feedback control system having characteristic equation given as S4 plus 2SQ plus 2S square plus K minus 10S plus K is equals to 0. See, we have done this question, similar question. Question number 44 and 49 both have same concept. So I think from now you can solve this question. There is no need me to give you the explanation for this one. Right? Now, coming back to next question. In next question, question number 50, this is the question of chemical technology. They are saying one column is your following catalyst is given, that is TiCl plus AlCl3, right? V2O5 FePD. Second column you have the product, that is ethanol, NS3, polyethylene, H2SO4. So for H2SO4 we have V2O5. For polyethylene we have Ziegler-Natta catalyst. This is TiCl4 plus AlCl3, right? Now for polyethylene, for P comes to 3, option third. Same goes for H2SO4, that is option Q, that is V2O5. For NS3 we have what? We have iron oxide. So for R we have option 2 in the column 2. For PD, see, PD for ethanol, we have Wecker's process. So, what is this thing? We have ethylene, right? So, for different values, you can say, you know the process, oxo process. You know this thing, na? Oxo process, right? We have to form what? Aldehydes. So in Becker's process, we are forming aldehydes and ketones by the use of what? By the use of solution. So write down that thing. Write down that thing because that thing is important. You have to learn Becker's process as well as oxo process, right? Now write down the things. In Becker's process, This, so write down this process. This is the process of oxidation. Write down. This is the process of oxidation of terminal alkenes. This is the process of oxidation of terminal alkenes to aldehydes and ketones. To aldehydes and ketones using palladium and copper compounds as catalyst. So instead of saying palladium, that is PD, they can also say that copper compounds as a catalyst. So instead of saying PD, they can give you Cu as a catalyst, right? So in Becker's process, right, we are oxidation of what? Terminal alkynes, right, to aldehydes and ketones. Terminal alkynes, right? Oxidation of this one gives you what? Aldehydes. So here they will give you ethanol, right? Or they will give you what? Ketone. It will give you ketone, right? So Becker's process gives you aldehydes plus ketones, right? Now, coming back to next one, next question. So, Becker's process is important. For this one, Becker's process is important. If you know, you can get the answer. Now, for the last question, we have what is the capital recovery factor if the number of annuity received is 10 using the interest rate of 15%. You know what is the meaning of capital recovery factor? In the formula of annuity. In the formula of annuity, we have what? Tell me, hurry up. We know that future value is equals to R 1 plus I power n minus 1 divided by I. You have to calculate present value. So we know that F is your what? P into 1 plus I power n. Put the value here, you will get what? P is equals to R divided by I 1 plus I power n minus 1 divided by I into 1 plus I power n. Right? So, this is the thing. So, we can say from here, that the reciprocal of this one, that is equals to this one, I into 1 plus I by 1 plus I power n minus 1. Recovery factor. You have to learn this thing as it is. If you know this thing, right, you will get the answer. So this is your capital recovery factor. Or you can say from here, what is the meaning of this one? This factor. This factor, write down, this factor is known as series present worth factor, and the reciprocal of series present worth factor is known as capital recovery factor. And I think you know the value of n, you know the value of I, you can easily get the answer, and the answer is around 0.1994 something, na? 45 or 5, right? So this is the answer. Simple question. If you know this thing, you can get the answer. If you didn't know this thing, you can't get the answer, right? Okay, next question. So in the next question they are saying capital cost of a pipeline, write down, capital cost of a pipeline of a material is given as 3D power 1.5 in rupees per meter, where D is your pipe diameter, capital D, in mm. The annual maintenance cost is estimated as 10% of the total capital cost. Total capital cost का हमारा, the annual maintenance cost is 10% of that thing. So if you know the total capital cost, you can easily calculate the maintenance cost. Now they are saying 10% of the total capital cost, and capital cost is given to you, that is 3 into D power 1.5. Now they are saying annual operating cost of a pipeline is given as, so I am writing now this thing, total operating cost is given as three into D power 15 divided by D power 5, right? That is in rupees per meter, rupees per meter year. This is 10, not sorry, this is not D, okay, this is 3 into 10 raised to the power 15. This is the thing, right? Now they are saying estimate the most economical diameter based on the least annual cost approach to the nearest multiple of 10 mm, right? Estimated amortization period is 10 years. So we have 10 years amortization period, or you can say up to 10 years we are doing this thing. Up to 10 years we are doing this thing in a simple language, right? So you have capital cost. What is the capital cost here? Total capital cost is given as 3D power 1.5, right? Now they are saying what? This is in rupees per meter. Annual operating cost is in rupees per meter year. So this is for 1 year, na? For 10 years, what is the total operating cost? 10 into 3 into 10 raised to the power 15 divided by D power 5. Sorry. This is your total operating cost for 10 years, right? Now see, they are saying economical diameter. Economical diameter based on least annual cost means optimization. That is the meaning of optimization. So if you know the total cost, if you can get the total cost, you can say, sir, total cost for this one is this thing, total cost of the plant is this thing, right? Or you can say total cost is this thing, and we can say by differentiating the total cost, we can get the answer, because differentiating of total cost and differentiation of that total cost is equals to 0 will gives you what? Anyone? Anyone? It will gives you the most economical diameter based on least annual cost. This gives you the most economical diameter. So, what is your maintenance cost? Annual maintenance cost. See, annual maintenance cost is equals to what? 10% of the, hurry up, tell me, 10% of the what? Total cost, total capital cost. This is given by this thing. So we can say 0.1 into 3 D power 1.5, and this is annual maintenance cost for 1 year. For 10 years for what? Annual maintenance cost for 10 years is 10 into 0.1 into 3 D power 1.5. Right. Now calculate the total cost. Total cost for the operation. So we can say total cost is equals to what? Tell me, hurry up. What is the total cost here? Total cost is equals to what? Total capital cost plus for 10 years. Total capital cost for 10 years. Right. And we know one thing. This is for per year. This is for 10 year total cost. This is for total operating cost. Right. And capital cost is what? Hurry up. So capital cost is for one time, na? One time investment is there, right? So this is a total. This is the total capital cost. This is total operating cost. For 10 years, this is the thing. So total overall cost is equals to what? Total capital cost plus total operating cost for 10 years. Total 10 years plus total maintenance cost for 10 years. This is the thing. You will put the value for this one, put the value here. You will get the equation of total cost, and you know the optimization means you have to differentiate this thing now. You have to differentiate this thing in order to get the diameter value. This is equals to most economical diameter to minimize the total cost. This is a minimization of the total cost now. We have to minimize the total cost. So this one, so for this one you can say it's a differentiation of total cost with respect to diameter and place this one is equals to 0 for optimization. You will get what? You will get the value of D, diameter. It is most economical diameter. And on solving this one, what you are getting? I think I am getting 3, the value of diameter is equals to 313.08 mm. And they are asking about what? The nearest multiple of 10 mm. So we can say our answer is 310 mm. Now they have asked you the most economical diameter. Now this is the thing. With the help of optimization, they can also ask you what is the value of total cost for most economical diameter. What is the value of total cost that you are getting for most economical diameter? So instead of saying calculate the most economical diameter, they can also give you the question that calculate the value of what? Calculate the value of total cost for most economical diameter. For that, first you have to calculate the most economical diameter, then you have to place this D value, diameter value in this equation to get total cost at most economical diameter. This is the thing. So instead of asking most economical diameter, they can going to ask you about the total cost for most economical diameter. For that, you have to calculate the most economical diameter with the help of optimization. Then you have to place the value of diameter in this equation. You will get the answer, right? So this completes the questions from plant design economics as well as process dynamics and control plus chemical technology and engineering mathematics. Now, if you are facing any doubts related to the concepts of these questions, or if you are facing the doubts in these subjects, okay, you can contact the institute, okay, they will contact me. So you can contact from there, right? So we will have a discussion regarding the concepts and you can ask me the question anytime, right? Now, that's all for today, guys. If you are facing any doubt, you can contact me anytime, right? That's all for today. Thank you, guys. So, right, if you are facing anything, any doubts regarding this question or regarding any concepts, okay, you can contact the coaching institute, okay, and they will arrange a meeting, right, face to face. They will arrange the meeting face to face, so we can discuss your doubts and doubts related to the theory regarding these subjects. Okay, that's all for today, guys. Thank you, guys.